Welcome to St Helens Morning Mathematics, Day 18. Obviously it's morning mathematics, we're doing arithmetic and place value where appropriate. So today you're going to need to have a pencil and some paper. If you've got squared paper, that's even better in order to make sure everything's lined up nicely. And then we're going to look at some questions. For year 3, you've got questions 1 to 5, year 4, questions 1 to 10, year 5, questions 6 to 15, and year 6, questions 11 to 20. Obviously, you can do any quantity of these questions that you choose to do. If you find my voice is a little bit annoying or it's putting you off, then you're welcome to mute the sound, or you can pause the video to give yourself extra time. Totally up to you. With that said, let's have a look at today's work. Okay, the first question is looking at 3-digit cards, and it's asking us to make the biggest or the largest value we can with them. And we know that in our number system, the digits are laid out such that the lowest value column is on the right and the highest value is on the left. So we're going to rearrange these. So we've got the smallest number, the smallest digit on the right. And looking at these, we'd look at the 2 and say that's going to be on the right first. 2 goes in the units of a ones column. It used to be called units for several hundred years, and recently they've changed it to ones, so you probably need to know both of them. It's useful. I still use units and ones, just to make sure that everyone understands the value of that column. Having used the 2, I'm left with an 8 and a 4. The 4 is definitely smaller than an 8, so the 4 would come next. That goes in the tens column. Crossing that one out, I can see I'm only left with the 8, so I don't really have a lot of choice anymore. So the 8 has to go there, and that gives me a value of 842. The next question, it's saying 255 plus 182. We know that plus is another word for add or addition, so we're going to be doing an addition question here. So looking at that, if I was to do that in my head, then I would probably do 255 plus 200 and then take away the 18, as that's quite close to 200 and it's a quite nice way of doing it. But to write it down, we'll use the standard column method and we'll write down the 255. Not that easy with a mouse, but we'll go through it anyway. Plus the 182. I'll remind myself of the columns. And of course, I'm adding, I'm plussing, so I'll put that sign there just to remind as I go along exactly what operation I'm doing. So this is quite straightforward now. I've got 5 and I've got 2, and I could go 2 plus 5, but it's probably simpler to go 5 plus 2. There's a bit less work in it, so I'm going to go 5, 6, 7. So I've got 7. This time the 8's first because it's large, so I'm going to go 8 plus for 5. So 8 plus 5, 8, 9, 10, 11, 12, 13. Carry the 1 to the next column. You could put it here, you could put it above if you wish. Some people would even put it below, although I don't recommend that as it causes a little bit of inconsistency when we come to doing multiplications later. So as long as you put it somewhere you don't forget, you're fine. 2, 3, 4 gives us 437. Obviously I've double checked that already by using my mental method. Adding 200 to this will give me 455. Then I need to take away 18, so if I take away 20, 433, and give 2 back, 437. Nice quick way of checking it once you're used to doing mental arithmetic in your head. Question 3, this time it's got the word minus in the question. That minus is telling us that we're doing a subtraction or a takeaway, so we'll need to remember that when we've written down the digits. So we've got 362 minus, I'm going to put that there just to remind myself what I'm doing, 191. The first step is quite a nice straightforward one. 1 from the 2, that gives me 1. I'm not able to take 9 away from 6. 9 is larger than the 6, so I can't do that, so I need to get something from the column next to it. Fortunately, this column does have some values in it. It's got 300, so I'm going to take one of those hundreds and I'm going to put it over here. But I must remember, oops, wrong way around. I must remember to cross this out, a bit hard with a mouse, put the 2 there, that's what I'm left with. Okay, now it's 9 from 16. So an easy way again, 9 plus 1 makes 10 plus 6, so I'm left 7. And 1 from the 2, that gives me a 1 there. If I had put hats on, I would have probably squeezed that in with more difficulty. So in this case, I wouldn't bother with the hats. Obviously, you're welcome to do so if you find it helpful. If I was to add 171 and 191 together, that would be my check. That would give me 362. I'll just change this to check that now. So 1 plus 1 gives me 2. 9 plus 7 would give me 16. 1 plus 1 plus 1 is 3. And as you can see, I'm now left with 362, which is what I started with. So I've checked my answer and it's definitely correct. Okay, the next question is 7 times 4, so let's just get rid of that line there. So we're used to the songs by now, and we can do either the 7 times table or the 4 times table, because in multiplication it doesn't matter which way around you do it. So I'll do 7 and 14, 21, 28. So 28 is an immediate answer. If you weren't happy about that, then you could do a number line. And again, with your number line, you could either do jumps of 7 or jumps of 4. Just in order to fit this on a bit more neatly, I shall do jumps of 7. So that's plus 7. Really difficult to draw with a mouse. Plus 7. Plus 7. And finally, one more 7. And then if I added these up, starting from 0, I've now got 7 by itself. 7 plus 7 is 14. Plus another 7 would give me 21. Plus the final 7, 28. There we go. Okay. Question 5 is 16 divided by 4. It could be 16 shared by 4 or split into groups of 4. So the easiest way of doing that is to do 16 dots. You can do them any layout you want. It would make sense to do 4 cross by 4, but let's imagine I didn't realize that, so I've done groups of 4 there. So now I need to split them into groups of 4. There's one group of 4. That's another group of 4. Another group of 4 there. And a final group of 4 there. So we've got 1, 2, 3, 4 groups of 4. Don't worry about the extra dots, they're just there while I'm working it out. So the answer to 16 divided by 4, quite simply, 4. Question 6 is very similar to question 1, just slightly larger. There's an extra digit card included there. So the same idea as before, we're going to be looking at making the largest value we can, and we know that the largest digit card would be on the left and the smallest value digit card would be on the right. So 0 is the smallest, so that would go on the right, and we put a line through it. We've now got 6, 9 and 9. Next smallest one, clearly the 6. We've got 2 9s left, doesn't really matter which one we use, we might as well put them both in. 9 and 9. 9,960, the largest value we can make. Quite a nice question just to get you going. Not too difficult. Okay, this one is a bit more interesting. Question 7, it's using the plus symbol. It tells us we're doing another addition. It's possible to do it in your head, but probably not much more efficient, if any, than doing it using the standard column written method. So we will do that. We've got 4,182 and 2,357. We've made sure to line up the unit to the ones column. Best way of ensuring that we don't make any mistakes later on. Have not forgotten that I'm doing an addition, so I'm just reminding myself, putting the symbol there by the side, and now I'm adding them up. 7 plus 2 gives me 9. Again, I'm going to start with the largest value each time, so 8 plus 5, that gives me the 13. Carry the 1, I've got a lot of space over here, so I'm going to put it there this time, just to show that you can do it different ways, it doesn't really matter. 3 plus 1 plus 1 gives me the 5. 4 plus 2, 6. And there's our answer to question number 7. Question 8 is looking interesting. Let's have a quick look at question 8. 4,111 reduced by 6,809. As usual with subtractions and takeaways, the larger value would go on the top until we start looking at negative numbers. So for now, got 1, 1, 1, 4. You might have noticed that I started on the right hand side this time. That's because I've got my line here, which means I know that this column here is going to be my units, my ones column, and so I'm ensuring I line everything up according to that. I'm reducing it, I'll just put my symbol there, by 689, so the 9 can go there. Okay, so first step is a little bit difficult because I'm trying to take 9 away from 1, I can't do that, so I'm going to cross out that one there, put a 0 above, carry that 1 over to here. Now I'm taking 9 away from 11 is 2. But again, that means I can't do this one, so I've got to carry again for this one. That becomes a 10, that becomes a 0. 8 from 10 is 2. 6 I can't take away from 0, so I need to take 1 from the thousands column and put it in front of the hundreds. And now 6 from 10, which is 4, and that leaves 3. And there's our answer to number 8. Our next question, 351 times 7. So I'm just going to move this bar a little bit. I might want to keep it so that I can partition the number. I'm going to do this two ways. I'm going to partition it first, and I'm also going to do the standard written method for multiplication. So multiplication, put my sign there, put my 7 there. It doesn't matter which way around you do this. As we know, with multiplication you can do it in any order. So I'm going to put 7 there, you could have gone with 7 here, and I'm going to do 350 and 1. I'm going to partition the other number up, and if it was a piece of paper I'd take more care to ensure everything went in a separate square. Obviously limited space on here, so I'm going to squeeze them up a little bit and use non-standard line widths. 50 and the 1. Let's just make this one a little bit larger if it lets me. Okay, oh, one more line needed. Okay, so 7 times 3, I'm ignoring these zeros because we know that if you multiply by 10 or 100, it just shifts the digits across by 1, 2, or however many zeros there are, that's how far it shifts them. So I can ignore that to start with. I can go 7 times the 3 to get 21. Then I can place these 2 zeros on afterwards. If there was another 0 down here, I'd have to include that as well. There isn't, so it's not something I need to worry about. Next question part to this is 7 times the 5. This gives me 35. And then there's only the 1 0, so I just include 1 0 there. Then 7 times this 1 to give me 7. No zeros at all in either column or row, so there's none needed. And now I just add these up. I could do this in my head, but it's probably wise to try and write that out as a column addition just to avoid any unnecessary errors. Just going to be a bit lazy there and put the line in. Remind myself it's an addition. 7 plus nothing is 7. 5 plus nothing is 5. 3 and 1 gives me a 4. And a 2 there. So there's my answer to that one, 2,457. I'll just redo this using the standard written method. Let's just clear out the annotations. Get rid of these pieces one at a time. Limitations of the input. And then let's work this one out. So we've got 351 times by 7. Nice line there, keep that neat-ish. 7 times 1 is 7. 7 times 5 is 35. I'm going to carry that there. If I was writing this with a pencil, I would have made this a bit smaller. Again, obviously at home, that's something you can do. 7 times 3 is 21. Don't forget to add the 3 you carried, becomes 24. And as you can see, you get the same value as last time. Let's move on to the next question. Number 10 says 483 divided by 3. Looking at that, I can use my knowledge about divisibility to say that 3 is definitely going to go into this number, so we don't have to worry about remainders. So we've got 483. We'll probably use the short version of division to do this, but I will show you that you could just as easily use a number line to do this as well. Number line is perfectly reasonable for this one. I'll try and do both together. So first of all, 3 goes into 4 once, and there's 1 left over, so we'll put that in the next column. Now 3 into 18 goes 6 times. There's no remainders there, so nothing to carry. And the 3 goes into 3 once, 161. Now if I was doing it here, I would probably have said, okay, I could do 100 lots of 3 to get 300. And then I could do jumps of 30, but I know my 3 times table, 5 3s, 15, so 50 3s would be 150. So if I add them together, that gives me 450. Difficult to fit on. I'm trying to get up to 483, so I've got 33 left, and now my 3 times table, I know that 11 times 3 gives me 33, which added onto there gives me 483, squeezing that on there. That means I've got 100, 150, 161 lots of 3, and as you can see, that's the same as the answer on this short method. So using the number line does work, just partitions it out a little bit more. Okay, that's the first 10 questions done. I've got to move this down now. So if you're year 5, this is probably time for you. You may have had a go at the previous questions as well, just to warm yourself up. Would have been a good idea. So question 11, it's asking us to put together a partition number. So we've got thousands here, hundreds, and a 3. Interesting that there's no tens there, so we need to really think about that when we come to put the number together. Optionally, we could write that out as a column addition, just like this. Put that together. And we'd get 3. There's nothing in this column. Have to remember that nothing, that's where people make mistakes. Get the 7 and the 4, giving us a final answer, 4,703. We could have said that to ourselves, 4,703, and that was the answer that would go in there. Okay, ooh, nice use of language for number 12. Use of the word combined, you don't see that too often. So we've got 79.2 combined with 4.58. So a few things going on here. We've got the use of uncommon language, combined, just means add or plus addition. And then we've got decimal numbers going to a number of places, so a mixed number of places as well. So always look at the question, try and understand exactly what you've got, what you're working with, as it helps you lay it out. We know that in our number system, the lowest value is on the right, and then the further across we go with our digits after a decimal, that's the lower the value. So in this case, that 800ths, definitely smaller than these 2 tenths, so that's going to be on the right. So we put the 8, 5.4. Now that we've got a decimal point in there, the next part we just have to line up a decimal point. Now it is a larger value, so I'm going to put it on the top, but really it makes no difference, it's addition, it could go either way around. Lining up the decimal point, and then the 2. There is a space there. Space is always 0 when it comes to mathematics when we're writing things down, but often it makes things easier to include that, so we do that there. Now I'm going to have to carry on even though we've had a bell ring, so let's carry on with this. We're doing addition. 8 and 0 is 8, 5 and 2 is 7, keep the decimal point in line, 9 and 4 makes 13, so 1, 7 and 1 is 8. Okay, moving on to question 13. Question 13, nice straightforward, 18,000 take away 12,584. Personally, I'd round up to the 13,000 and then just add on 5, but we'll do the formal method as well. We've got 18,000 take away 12,584. Get a line going across here. Can't take the 4 from anything there, so we've got to go along until we find there's one, so that's a column that has a digit in it, so we'll do that and we carry it all the way through. We can't just skip straight to the end with that, we have to carry it across each one so we know exactly what we've got left in each column. 4 from 10 is 6, 8 from 9 is 1, 5 from 9 is 4, 2 from the 7 gives me a 5, and the 1's cancel out, put a 0 there. So that leaves me with 5,416. A little bit messy, but it's correct, so we're happy. Number 14, the product of. Product means multiplication, so a product of 652 and 15. Again, we can use different methods. We'll use the grid method for now. So multiplication, let's put that sign there. I'll go 600. 52, and I'll multiply it by 15, which I'll partition into a 10 and a 5. Right, this one again I'm going to ignore a 0, so it becomes 1 times 6, 6, and then there's 1, 2, 3 zeros all together, so I've got to include them. 1 times 5 is 5, and in this one there's 2 zeros. And this is the interesting one. So 1 times 2 is 2, but the zeros over here, it makes no difference, we still include it. So it becomes 20. 5 times 6 is 30, and with 2 zeros, if we look up here, 5 times 5 is 25. With 1 0, and 5 times 2 is 10. We add these together, we're going to get 6,003, so it's 9,000. 500, 200, 750, and 30 there. Quickly add those up. We get 0, 8, 7, 9, 9,780. That's that one done. Clear this. Okay, next question. Number 15, 8,475 divided by 3. This time I am just going to use the short method. Let's use a smaller pen. 8,475 divided by 3. 3 goes into 8 twice, leaves 2. 3 goes into 24 8 times, no remainder. 3 into 7 goes twice, 1 remainder. And 3 into 15 goes 5. So we've got our answer there, 2,825. Well, that was very quick, so let's quickly and rapidly move on to the year 6 questions. There's not many of these. So again, it's partition 1. Notice there's a 10 stuck in the middle there. But we could just look at that and say, okay, we've got 2,000, we've got 460 and an 8, so it's 2,468. Or we could write it out. Forget it's an addition, and we'll get the 8, 6, 4, 2, 2,468. Moving on. Oh, combined. Oh, we've used that word twice today, that's good. 2.45 combined with 8.99. Another one, it's addition again. This time the decimal places do line up nicely, so there's nothing to worry about there. So we can write 8.99, decimal point lines up. 2.45, it's addition. Get our line out. Keeping it neat. 5 plus 4 is 14. Have a 1 over there. 9, 1 is 10. Number bond, always good to spot them. Another 4, 14. Got to remember the decimal points always line up, so put that there. 8 and 2 is another number bond to 10. plus 1 is 11, so we've got 11.44. That's our answer to question 17. Might be going a little bit faster now, so if I am, you might want to pause the video however it's appropriate. Okay, next question, what have we got? Number 18. 5 take away 3.578. Again, if I was doing this mentally, I'd add up from the 3.578. And I'd think of it as 578 to the nearest 1,000 plus 1,000. However, we'll do it as a take away, written method. Got 5, and we're taking away 3. Notice those two are under each other because they've got a similar positional value. They're both units, so they have to be underneath one another. 3.578. And because we're doing a takeaway, it's really sensible to put in those zeros. Fill it in. Okay, and with that, we're trying to take 8 away from nothing. We can't do that, so we're going all the way to the end. We're changing that to a 4. We carry down all the way until we've got something in this column that can work. 8 from 10 is 2. 7 from a 9 gives us 2. 5 from that 9 gives us 4. And 3 from the 4 is 1. So 1.422 is our answer to question 18. Question 19, this time we'll just do the standard method for multiplication. And we'll get rid of that line for the moment. So we've got 342 times 67. I wonder if there's any kind of set pattern or anything we can see about the number of rows we add up depending upon the value of the multiplicand over here. Might be something worth investigating in your own time. So, first of all, I'm going to start off with the ones, the units column of the lower value. It doesn't really matter whether you start at the bottom or the top values, whichever way works for you. I'm starting with this one, but multiplication can be done in any order. So 7 times 2 gives me 14 over 1. 7 times 4 is 28. Got to remember to add that 1, so that's 29. And I'm just going to cross that 1 out because I've used it now. 7 times 3 is 21, plus that 2 I carried becomes 23. And again, just so I can get rid of that because I've used it, it doesn't want to confuse me later on. Now I'm multiplying by the digit in the tens column, so I'm going to put the 0 there straight away because I know I'm multiplying by 10. 6 times 2 is 12 over 1. 6 times 4 is 24, plus that 1 there becomes 25. And again, get rid of that, it's been used. 6 times 3 is 18, plus the 2 becomes 20. And again, get rid of that because I've used it. Get my line across there. Now I've got 2 rows that I need to add up. I'm going to put the add there. Normally I'd put it over here, but I haven't got room, so let's do that. 0, 4 is 4, 9 and 2 is 11. I can put 1 there. Notice because I've crossed out these other working out, I know I'm not going to be adding them on as I add up this column. 5, 6, 9. 2 and nothing's 2. And a 2 there, give me 22,914. So now we've only got one more question left, and then we've completed today's work. Yeah, I'm just going to move this across. It's not quite straight, it annoys me a little bit, but we can live with it. I'm going to move that down there and go across here. 18,000 divided by 4. 4's on the outside, that's what we're dividing by. 18,000 goes in here. We know that 4 definitely goes into this. All we have to do to know that is look at the last 2 digits. If 4 goes into those, then we know that the number can be divided by 4 without any remainder. Just playing about with that there, just trying to make it a little bit neater. There we go. So, 4 into 1 doesn't go. Carry the 1 over, next column. 4 into 18 goes 4 times. 4 into 20, we know that goes 5 times. And then we're left with the zeros. And that's our final answer, 4,500. So bringing up all the answers together, see them all there. Hopefully you've enjoyed today's lesson. I look forward to having the rest of your day.